I sort of cleaned up our to-do list just so it's like always loud and clear on the screen, so we know what we're on. And an interesting thing I've noticed after this short time of making these videos is that I'm able to understand the material myself a lot more just because I'm talking through the videos. So that's pretty good. So yeah, just to recap, we're on chapter 3, still reading through it. It's a very boring chapter just because we have to learn about like time complexity. So, but it's not too bad. It's not too bad, honestly. Not too bad. Not really bad at all. And then this is what I want to start with today. Modify. So, yeah, just to explain a bit, what I'm trying to do is I found this open source lap time simulator online called Open Lap Sim, and it's a pretty cool piece of software. And I wanted to. It's a point mass piece of software. It's a point mass simulation, steady state. So I wanted to create a derivative version of it, but the vehicle model, it's a bicycle vehicle model. So it has an extra degree of freedom. So that will change how the car's GG diagram will look, or GGV diagram. So our task is to modify the current equations created by the owner of OpenLabSim, and that way we sort of get to learn more about what the internals of a simulation software look like, a simpler simulation software. So I did write a blog about this called this one. I was trying to walk through how the internals of that Python file actually worked. So we can actually just refer back to this. Yeah, okay. So this is the file acceleration envelope calculator. Oh, we don't need to touch the powertrain model today, I don't think. Or do we? Okay, I do know we have to do 2 different aero models. So let's go back to where is it? There it is. Yep, this one. Okay. I want to take notes of this because let's try Pages today. Bro, I have to download that joint. Okay. No fancy UI. Come on. All right, let's make a new folder. Man, hold on. So, how do I make a new folder? Because I feel like documents. How do I make it? Oh, let me do this. Wait. What the hell? Alright, whatever. Awesome. Bicycle model in open lab. You know, one issue we'll have to see. Okay, never mind. I'm not gonna say anything. Okay, how do I make this go? Okay. The steady state. Yeah, so there's a normal force change between the front and the rear axles, and it is a function of the wheelbase. How do I do math? Oh, sweet. What? Oh. Yeah, I might have to stop using enter. This is annoying. Very cool. I just want to center it though. Wait. Text? No. Dude. Oh. Okay. Sneaky. Okay, this is very nice then. Awesome. Pitch angle. How the hell are we supposed to account for pitch angle? And influences its aerodynamic performance. Okay. So it's a more accurate, so we need a more accurate aero model and load transfer model. Okay. Damn, my stomach. I'm hungry. Hope y'all didn't hear that. We're gonna get back to these later. I mean, obviously, like, we already know it's gonna be vehicle center of gravity. Height of center of gravity. Wheelbase. And I don't know what else, but we'll have to get back to this. Okay, this sentence keeps evading me. It's a very important sentence, but I just don't understand it. An important aspect of this distribution is the aerodynamic balance. Okay, so we have to consider the aerodynamic downforce distribution. This is... Okay, so the car, there's an aerodynamic balance and a center of gravity balance. Oh, I think what it's trying to say is that since the downforce is different on the car now, it's like a seesaw, right? There's more weight on one side, and that mess changes like the aerodynamic balance. That's what I'm understanding from this. I think this is true for us as well. Bro, we can't just change the equations. We have to do this. Okay, so we know exactly what needs to be calculated. Maybe we don't need to use, I don't know, because what happened with this code, like in our case, how it was calculated was with an error right here. The lateral acceleration. Since the lateral acceleration is a function of, I think the it's a function. Hold on. Okay, ours is gonna be like something like this, but different. Very different. I don't know. Oh wait, this is for calculating the lateral maximum velocity. Oh, this is maximizing the Vmax. Oh, dude, okay. This is talking about this. Okay, this. Wait. Oh, I see. So it's this equation equals A, and we're basically trying to make this difference as small as possible by incrementing Vmax. And yeah. It's funny, I wrote this myself, but this is what happens when you don't review stuff for months. Because I wrote this like 5 months ago, 3, 4 months ago. Oh yeah, so I guess when this approaches zero, the lateral acceleration would turn zero because it's eight. Oh my god, I need to read my own stuff better. Dude, okay. Okay. Alright. Okay, we need to find out the lateral acceleration. So first a vector with list with n steps is initialized. That ranges from 0 to v max, called vx vector. So now we calculate the lateral acceleration as a function of the range of velocities. And yeah, it's not... Yeah. Okay, now let's see how they do it. Okay. Normal force times... Oh, okay. Now it's just... We just have two normal forces, so we add them. Okay, so we just add them. Wait, no change in longitudinal acceleration? Wait, no, hold on a second. This is longitudinal acceleration. Oh my god, this is... You have to be so... I have to be so careful when reading this stuff. Oh wait, no, to find the maximum lateral... Hold on. Oh, okay, so we need to use the optimization solver. Okay. Finding maximum... Hold on. I'm back. My bad. Can do multiple lines. Shame. Okay, like this is easy. Like we have this. So it seems like most of the work has been done. We just have to figure out the maximum longitudinal acceleration. We do have to go back to see how we calculated, not me, but the software calculates it. Oh, why am I on this page? Okay, so my fault. Zoned out. I would really like this editor. I was using Overleaf this whole time, but This is really nice. Because you can do everything outside of what overleaf does. But you have the benefit of having the most important overleaf functions. Alright, I'm not gonna pretend like I know exactly what this means. I know this is like the equation for an ellipse, so is this interpolating the points in between? What is AY? Oh, it's interpolating the lateral acceleration, I'm guessing, in between points, I think. Something like that. We'll figure it out. Bruh. It's a shame this is taking me so long, but oh well. I mean, I'm starting to get it a bit. Okay, you know what? Let's not even worry about the pitch implementation. I just want to get this one done with. Oh wait. Oh yeah. Let's see how the longitudinal acceleration is calculated. So we do have the powertrain model. Okay, it's the minimum of the tractive capacity of the car and the grip capacity of the car. Because tractive is referring to the engine output, I'm gonna hazard, and grip is referring to the tire grip, I think. Because if it's more than the grip, then it's gonna wheel slip. See, yeah, it's the same one. Alright, now we have to. Okay, what. Okay, but like it doesn't even say what the model is. Okay, you know what I'm getting from this is that we don't even need to use an optimization solver, iterative optimization, because it, there has to be something more. What? Okay, I don't know if I'm missing something here. Oops. Oh, it's IP opt. I've been saying I popped.